Welcome. In this lesson, we are going to be looking at a very critical and important aspect of Power BI, and it is something called DAX or Data Analysis Expression. So, in the last class, we've looked at one important component of Power BI, which is visualization. But in this one, I want to look at is DAX. So the entirety of what Power BI is Power Query, visualizations, and DAX, in my opinion. Also, there is normalization, data modeling. They're also going to be looking at in the future class. But um, the very important thing about this class is that we need to understand how to actually do some um, data wrangling on our data set that aids better visualization, better business intelligence without necessarily doing it inside Power Query. And this bit is important. What we use data and what we use DAX for, and the meaning of that DAX is data analysis expression. What we use for DAX for is for giving set of instructions to Power BI regarding our data set so that it returns some output for us. Sometimes, majority of the time, not even sometimes, majority of the time, the data set comes in, just normally. There is no calculated tables, no sum, no averages and things like that. And you want to do something like that in your own dashboard or in your report. So what helps you to do that? What helps you to do calculations here and there, you know, analysis here and there? What helps you to do that is DAX. And we are going to be diving extensively into it in this class. It is a very simple complex, it is not overwhelming. And yeah, let's get it. So firstly, what I would like you to do is open up your Chrome, your or any web browser that you are using, and go and search. I would like you to go search DAX Power BI like this, or you can add documentation. Yeah, I think we don't need to. I think that returns this thing. We need to download the documentation so we can click on this first one from Microsoft Learn, and it should bring us here to a page like this. And all you have to do is stay on this left hand side where my mouse is currently and scroll all the way down. Then you're going to see download PDF. So I'd encourage you to download that. So Microsoft has put together a very solid documentation. So in your case, I already have it, but this is it here. So in your case, you might still want to click on this download so that it saves locally on your computer. Now, here's the thing. The thing with documentation, especially if you already have any idea with programming, is that, you know, for example, DAX now is a library, right? A library of functions based on their own explanation here is a library of functions and operators that can be combined to build formulas and expressions in Power BI, Power Pivot, blah blah blah. Now, because this thing is a library, you are not required to memorize everything. In fact, it changes from time to time. So what you really want to do is you want to have this thing, and it's a bit voluminous. It's about 1,135 pages. But you just need to treat it like your Bible, right? So like the Bible of Power BI. So whenever you are working, like a Bible of DAX, sorry, whenever you are working, you're building something, and you need to use some DAX here and there, you can always come to the documentation here. And there are a few things. If I switch this here and click here, I can really get a table of you know, uh, content. If I'm interested in aggregation function, let's say I want to look at how to do averages, I want to get clear explanation, right? Okay, what does averages apply to? Applies to calculated columns, tables, measures, visuals, returns the average arithmetic mean of all the numbers in a column. Now, if this explanation looks like what I want, easy stuff. I just come here and look at the syntax. So the syntax is to say average, then you pass the column name, and even this column that they've passed in, we call them parameters. Even if you don't understand what the parameters mean, you can come here and like read the definition, the column that contains the number for which you want to average. So it's really really very nice. You are even going to get example. I think so. Yeah, like an example use case. If you scroll all the way down, can you see? So it equals average internet sales, extended sales amount, right? So that is that. In the course, occasionally, but not every time, so that this video doesn't get too long. Occasionally, I'm going to come here to just reference some DAX, like to show you this structure. Uh, but usually I'm not going to be coming here. But in your case, you don't need to memorize anything. All of the functions, they are we are not even going to cover 5% of it in this video because it's a lot. Like it's a lot. But anytime you need anyone, just come here, look at the same way we are going to implement in this video. That's how you are going to be implementing it. Look at what it does. If it is suited for your use case, read up on it. So what you want to use is max x. Read up on what it does. Read up on the definition of the parameters. Then read up on how to implement it with the syntax. If that is not clear enough, go to the example, read up on the use case in the example. If it tallies with what you are doing, look at how they implement it. And you're going to get like multiple examples, right? So, yeah, so let's get into this part. So, DAX generally is divided into three, right? So, there is measure DAX, there is column DAX, and there is table DAX. Measure DAX, column DAX, and table DAX, right? So, what is measure DAX? What is table DAX? And what is column DAX? So let's start with measure DAX. So any DAX that we write and it returns a single output, like the output of that DAX is a single value. For example, whenever you compute the average of a column, you're not expecting multiple answers for the average of a column. You're only expecting a single answer, like one single answer, one single response. So that will make it a measure DAX. That will make averages a measure DAX. Something like sum. If somebody should walk into your establishment and say, what is the total amount that you made? What is the total profit that you made this month? You know that the answer to that is going to be a single value. Say we made 50K this month. So if you want to do something like sum, that's also going to be a measure DAX. So measure DAX are DAXs that we write, and the expected output is just one value, a single value. So right, that's where we're going to be starting. So, but we cannot do anything in Power BI until we get um data. So we're going to be using the sample data that we've been using since the start of this course, and it's coming up. It's coming up. I hope that doesn't take too long. Still coming up. Okay, yeah. So we're going to click on financials. This financials here, and it is going to load up this same data set that we're using the other day. Then we're just going to click on load. Don't forget that in the class on Power Query, I explained to you if you intend to like clean your data, you should click on transform data. We're just going to click on load the data straight into Power BI and get started writing DAX. So this class is just going to be focused completely on DAX, on writing DAX. So we are coming up, and while we are waiting for it again, let me go over what measure DAX is. Any DAX that we write and the expected output is a single value, that is a measure DAX. If the expected output is a column, that is a column DAX, and if the expected output is a table, that is a table DAX. So now let's get into how to write it, how to write DAX. Now if I want to write a DAX, a measured DAX in this case, I one thing that I personally like to do, you can stay on any page, but one thing that I do personally is I like to stay on the table view when writing DAX, so that I'm closer to my data in a way. You can write DAX on any page, it's gonna work, but I just like to stay on this page. And what I like to do is now, now that we are here now, the first thing you want to ask yourself, and that's one thing I like to do, is what kind of DAX am I writing? And there's really no way you can uh, succeed at writing this thing without knowing beforehand the kind of DAX that you want to write. Because if you go and write column logic into a measured DAX, it's not going to work. So the first thing you ask yourself is, if I write this thing correctly, what does my expected output, what does it look like? So, okay, if I want to return, if I want to write a DAX that returns the profit, total profit rather, total profit made, like total profit made, that's sum of profit. And what, how many values are we expecting if we write this thing correctly? Well, we're only expecting one output, just one output. So in that case, what we are going to be doing is we are going to be writing a measure DAX. So I already know I'm going to be writing a measure DAX. So I can either come here and click on new measure, or I can right click on this and click new measure. Anyone works. So I'm going to click on new measure. I didn't click on new column because what I want to write is a measure DAX. Now, I get this place for me to write my formula in, or my DAX in. So I'm going to make it bigger, and you can zoom in also or zoom out with your mouse, anyone that you want to do. Now, the structure of a DAX is like this. The DAX is going to have a title, then we have this equal to, and you can have the logic, the function, the operators, and everything. And also there can be comments. So I'm going to show you this. So what we want to do is total profit. So I'm going to say total underscore profit, which is the name of the DAX, the title of the DAX. That's the first thing that you must always include, the title of the DAX. Then after that, we say equals, and I can just write sum, this is sum. I can say sum, and if I say sum like this, I'm going to get this thing where it is explaining to me like this IntelliSense, this further explanation on how sum is expected to work. So sum as a function takes a column name that you want to sum together and add all, then it's not explaining to you what it does. It adds all the numbers in a column. So what column name are we trying to sum together? That is profit, right? All I have to do is do profit. Excuse me. I have to say is profit. Now you're going to see that I was typing profit. That suggested for me this is profit. That's because, okay, let me click on this. Now we don't just use only column reference in Power BI DAX. We reference both the table name and the column name. And the reason is because it is possible for you, in fact, it is usual for you to have multiple tables. And you can have multiple tables with the same column name. So you want to be able to like distinguish them clearly. So, and that's the reason I tell people, if you want to sum profit, do not start typing the table name first. Even though that's the first thing that comes. Just type the column name. It's going to suggest for you. Then you click on that, and we close this. So if we run this, it works. It is going to work perfectly. But then one nice thing that I like to do for readability is I like to include comments. So I can take this to the next line, or let me remove all of this. And before writing the logic, I want to include the comment. So I'm going to go to the next line. The way to go to the next line is to hold shift and press enter. So it takes the cursor to line 2. Then I can use double forward slash to write a comment on a comment about what this DAX is expected to do. That's a way of talking to my future self or talking to members of my team that this is what the DAX that I'm doing, that I'm writing. This is what it does. And you might be thinking, well, in this case, it's just sum, it's easy. Well, what if you now get to complex DAX? It's easier if you have comment than having to like bang your head against the wall because you cannot remember the DAX that you've written, let's say 3 months ago, 6 months ago. So in this case, we are going to say returns the total profit made. Then I can hold shift enter, go to next line, then write the logic sum profit. Then like this, can you see? So this is the logic, this is the comment here. Then I can press enter. And once I do that, you're going to see, okay, let me make this smaller. You're going to see, once I do that, you're going to see this thing that looks like a calculator here. This thing that looks like a calculator here. So whenever you see something that looks like this calculator sign, that's Power BI's way of telling you that this is a DAX. And now a measure DAX, I told you earlier that a measure DAX returns only a single value. Like a measure DAX returns only one value. So it means if you check your table here, you're not going to find it. Not going to find total profit. So we use measure DAX inside visuals really. Before we can actually see the output of a measure DAX, you must put it on a visual. So let's just use a card. In this case, I'm going to click on card, and this is card here. So I can take total profits that we just created, put it on card here, and this is it here, 16.89 million. And that is the way to create, to write DAX. And we've written our first DAX. And the first one that we've written is a simple measure DAX for computing averages, direct averages, right? So another one, let's look at another one. Let's go back to the doc, and I'm just going to show you. So for, this is aggregation functions, right? And under aggregation functions, we have a few things. There are a lot of them. Average. What's this? Approximated. What's this? Let's click. Okay, distinct count. Yeah, approximate distinct count. Average or average X. Count rows, max, mean, product. So you're going to see that all of the average thing that you have here, all of the aggregation that you have here, they are either average, count, maximum, minimum, or product, right? But then you are seeing this sign like extra X sometimes, then extra A sometimes. So we're going to explain what each of that means. So these ones that do not have X or A, this normal average, normal count, normal max, normal minimum, they just do your normal aggregation, right? For example, let's look at sum. So look at sum, it adds all numbers in a column. That's just all it does. Straightforward, adds all the numbers in a column, nothing special. But then sum x, what does sum x do? We call it x function. Sum x, count x, all of that. They are x functions, and what they do is they actually perform a row level operation before doing the direct aggregate. So this one says it returns the sum of an expression evaluated for each row in a table. That is, before we proceed to um, perform the aggregation, the summing, firstly we do some row level operation. So let's go look at um, one application here. So let's say um, we want to compute the total amounts that we paid in tax. We want to compute total profit tax, for example. Well, one thing to do might be, let's say tax is 4% of how much we make in profit. So any amount that we make in profit, we have to pay 4% of that in tax. So first thing to do is, subtract 4% from this. Is that right? For each one, put it in a new column, then sum all of that together. Well, that is where X function comes in. We don't need to do that first. We don't need to do that first. So what we just need to do is to write an X function and put the expression for subtracting tax firstly, then we can now sum over all of that. So let's see how that works. We are going to have a new, we are going to click on a new measure. That's still going to be a new measure also, because the output of that is still a single value. So I'm going to drop this down so that you see. I'm going to drop it all the way down. So we're going to say uh, total profit tax equals, then I'm going to say returns the total amount paid in profit tax. Profit tax is 4% of the profit made, of of each profit made. Right? Good. That's the comment for us to remember. So we are trying to return the total amount paid in profit tax. Profit tax is 4% of each profit made. Now, how does that now work? We are still using our profit table. So the first thing we want to do is, what do we want to do? Is actually total. We want to compute total. And to get total is sum. But actually, is sum. But in this case, we want to firstly do some row level operation. We want to compute tax before now summing the whole thing together. So that's going to be sum x. Now it says returns the sum of an expression evaluated for each row in a table, which is what we want to do. In our case, we are going to return the sum of profit tax that we've evaluated for each row of profit in our table. So the first thing that goes in is the table name, and our table name is financials, and that applies to every x function. Any function that bears x at the back, the first thing that goes into it is the table name. So after the table name, what's the expression that we want to do? The expression that we want to do is we want to multiply profit, total profit, financial profit multiplied by 0.04. That's 40%. So if we multiply financial profit by 0.04, that is going to give us 4%. Then we sum whatever that is together. So we enter that and it is going to run, and we have our total profit tax here. We can come to our visual, click outside, get a new card, put total profit tax on the card. So the total profit tax that we paid is 675,000.75. So that is X function. So this the one here does direct sum. The one here does sum, but by firstly doing some row level operation. And the same thing goes for max x, returns the highest value that returns from evaluating an expression. So takes first in table, then the expression. Same thing with min x, count x, anything, right? So yeah, that's that. Now the next one that we are going to look at is this A, but it's actually not that serious. So for example, average itself, average returns the average, the arithmetic mean, right, of a column. But what does average A? What does it do? Average A returns the average arithmetic mean of the values in a column, handles texts and non-numeric values. So in the event that you have text and non-numeric values in your column, average A is going to handle it. So if we are going to look at this remark in a little bit in a moment now, but let's say if you have a column that has numbers all through, the result of average in that particular column is going to be the same result as average A in that particular column. Now let's look at this remark. So in this remark here, it says the average A function takes a column and averages the numbers in it, but also handles non-numeric data types according to the following rules. So what's the following rules? Values that evaluates to true counts as 1. Values that evaluates to false counts as zeros. Values that contain non-numeric texts that are not numeric words, they count as 0. empty text also counts as zero, right? So that is basically what happens. And if you do not want to include logical values and text representation of numbers in a reference as part of the calculation, you probably should just use average, which is what I have said earlier, right? So now look at this example here. It says transaction ID and the amount, and we want to take average A of amount. So we want to average this column, right? So the column has 120 NA, completely missing value, like blank value, then the number true. So in this case, 1 is a number, it's going to be counted as 1. 20 is a number, it is going to be counted as 20. So we have 1 plus 20, but NA is not a number. It is also not a text representation of a number. So that's going to be counted as 0. This also is going to be counted as 0. This also is going to be counted as 1. So it's going to be 1 plus 20 plus 0 plus 0 plus 1, which is 22, if I'm correct. And 22 divided by 1, 2, 3, 4, 5. That's going to give us the answer here. So that's just basically what average A does. But if you do average A and you have all of these places to be numbers, like all of this, they are all numbers. It is the same thing as doing average, the exact same thing as doing ordinary average. But this comes, and that's why I used to tell people, like in data analysis or business intelligence, you really should not have, okay, yeah, this is the 22 or 5 that I said earlier. So in data analysis or business intelligence, you really should not be averaging a column that looks like this. You should not. You should be cleaning it. If you have an amount column that is this is dirty, this is not clean. So you probably should undo this before having to even get to the part where you do average. And that's why you are going to see that something like average A will not have so much popularity. You probably will not be seeing it a lot of time in your career as a BI developer or a data analyst or a data scientist that uses Power BI. So that is average A. So don't forget, this is what average A does. Some or all of the A's, count A, average A, all of that. What they do is they apply this exact same rule, right? So they apply this exact same rule that we just went over. The same thing with max A also, you know, that same rule. You can come here, you read about the rule here. But what does X, what does average X or sum X or count X, what do they do? We call those ones X functions. What do they do? They evaluate uh, our aggregation based on uh, a row level operation. Firstly, they perform a row level operation based on an expression that we've given them. Then they now perform aggregation on that, on the result of the row level operation that they had already done. Perfect. So that is that. So let's move on to the next one. So the next one I'm going to like to look at after aggregation function is logical functions. And like I said, we are not going to be looking at the entire thing. I'm just going to be looking at the very, very important things. Okay, let's start with filter and look at calculate. Calculate is extremely, extremely important also. So what does calculate help us to do? So let me show you this. So calculate is how we do uh, filter, and in a total way. We do filtering in a way that is total and that is very, very compact. And what does that mean? Let's say, let's come here. I want to know, let's say what I want to know is, we want to know the total profit made in Germany. We want to know the total profit that we made in Germany. The way to do that would be to come here and say new measure. That is still going to be a measure because we expect it to return one single value. If somebody should ask you in your business, how much did you make in Germany last year? You are not mentioning multiple values, you are mentioning one. So I'm going to say Germany or German profit or Germany underscore profit. And we can go to the next line and say returns the, let's use average. We've been using sum since. So say average. Say Germany average profit. So I can say returns the average profit made in Germany. So how do we do that? There's a condition now. And if you've already learned SQL, you can think of calculate as the where clause of Power BI. So in this case, we just say calculate. So whenever you have um, context in the problem that you are doing, for example, the context here is we don't want to see all of the profit. We only want to compute the profit for just Germany alone. So you know that you need calculate in that case. And how does calculate work? Look at it. Firstly, you get your expression, the normal expression, which is average. Sorry, average. And what are we averaging? We are averaging profit, right? Now, this is the normal expression. Now, the next that we pass in is the filter, like the clause, the conditions. So, what's the filter in this case? The filter is that the country has to be equals to um, Germany, and you use double quote. It's important that you use double quote, not single quote. Germany, and we close that bracket. So what do we have? We have calculate this thing, which is average profit, but only do it for countries that are what? Germany. So we should run that. We have Germany average profit is here. We can switch this to that and get a new um, card and throw Germany average profit on that. And we see that Germany average profit is what 26.29k. So that is how you do filter. Another very, very important thing that we're going to do is we're going to come back to, we're going to click on this. If you want to edit, and this is going to be an opportunity for us to learn how to edit a DAX. So if you want to edit a DAX, let's say you have a DAX, you want to edit it, all you have to do is click on it. I want to edit this Germany. It brings it up like this. So I can make it bigger and zoom in so that we see, right? Now, let's say I want to edit this, and I actually want to edit this because I want to show us not just only how to use a single condition. Let's say we have multiple condition. How does that work? So let's say we want to get Germany average loss. You know, for something to be loss, the profit must be less than uh, um, zero, right? For example, if we go back into the data here, this is the data here. Let me make it smaller. If you come into the data and you see profit, profit is not just profit alone. Loss, there are losses there. So I should click down on this drop down arrow here. I can see that there are a lot of losses. All these negative, they are losses. All these negative like this, they are losses up to this place. Let's say we want to see loss. Like I want to see average loss. So I'm going to click on Germany average profit, and I want to edit that DAX. Click down here. So how do I do that? For something to be lost, it means we need one extra condition. And the extra condition is that the profit must be less than zero. So what do? We say comma filter 2. I'm going to say profit, financial profit is less than zero. That's everything. And basically, before I click enter, basically what we are saying is we have two conditions here, and the logical operator between these two conditions is and. So we are saying give me the average profit in places, I'm sorry, give me the average profit for orders that we sent to Germany and in cases where the profit are less than zero. So basically what we are looking for is loss. Let me see, average loss made in Germany. So we just enter this, excuse me, enter that, then go back to and go back to this place. Once it's done, yeah, it's done. So we can go back to this place and check. So we see that the average loss, on average, you are making 12,777 something in loss in Germany. So uh, um that is a case of multiple condition, and this, I mean, if you don't want to use comma, so by default, if you add comma to condition, like you can do multiple conditions in calculate, and you can, delimit it by comma. And once you do that, what you are telling Power BI is and. You are saying this is and. That is this true. These two conditions, they must be true. Is that right? And that works with, if I also do double ampersands and like this and run it, I'm still going to get the exact same outcome, 12,007K. Can you see? It has not changed. Negative 12.77K. And it's still almost the same thing. If you are coming from Microsoft Excel, if you have any experience with Microsoft Excel, you can also do something like and, where instead of doing this, you can come here and say and like this, and open your bracket like this. Then instead of having this here, you can say comma, then close that extra bracket. So what does that mean? We have this function and that ends here. So I say and financials country equals Germany and financials profit less than zero. And what it resolves to, like if you run it, what it brings out is if the two conditions or however many conditions that you have inside this and, if they are all true, it is going to return true. But if one of them is false, it's going to return zero, false. So if I should do enter, I'm going to get the same output, which is the same 12,077K. So it depends on what you want, what works for you, the easiest thing that you find. But in the case of all, so I'm going to do that differently so that we don't make this too um much. So we don't like edit this too much. So let's get a new measure DAX. And in this one, we are going to be trying to get new measure. Uh, New measure. Perfect. So this new measure is going to return, let's say Germany, let's say Canada or France. Let's say Canada, France, total order. To returns the total number of orders sent to France and Canada. Right, in this case, we want to return the total number of orders that was sent to France and Canada. Right, and English language is generally is a bit ambiguous, right? So in this case, you say France and Canada, but it is impossible to send one order to two countries. It's not possible. Like one, let's say I order a laptop from eBay right now. They cannot send that one unit of um laptop, that same one laptop. They cannot send it to two different people or two different countries. It's not possible. It has to go to one place, right? So that's the reason why. And if we do this with and, it's not going to work. It's going to return zero. So let's do that. Let's do it so that you see. We're going to say calculate. Why are we doing calculate? Because we see that there is a condition. The condition is that the thing that we are looking at must be, the number of orders that we are counting must be either the one sent to France or Canada. So we say calculate, and with the after calculate, what's the expression that we are trying to work with? That's going to be count. So trying to use count, and what are we counting? We are counting anything. We're going to count the tables, right? So you can basically just do count rows. count rows so that it does not confuse us. And you can do count. If you do count too, you get the same thing because columns don't stand in isolation, right? So if I count country, for example, if I count country, it's the same thing. Like if I count column country, it's the same thing as counting column product. It really does not make any difference. But just for readability, whenever you are counting, you always do count rows. So and count rows takes table name, then comma. What's the next thing now is the filter, right? So if we use and, I want us to use and first so that you see how that is wrong. We're going to say and sorry, country equals Canada. Is it France and Canada? Yeah, I think so. Canada, comma, country equals France, right? So if I should run this, yeah, I think that's cool. If I should run that and throw, let's make it smaller, throw that on let me get the card out and throw France, okay, Canada and France, this is it here. But I should throw it here now. And you see, it says blank. Why is it blank? Well, because of what I explained earlier, it is not possible for you to have one order, a single order that was sent to both Canada and France. The right thing is or, like or. And I told you this comma in Power BI acts, especially in calculate, acts like and. Do you understand? So how do we do or? So what we use is this or sign, and we use two of it like this straight line. So we enter that and let's check. Now we see that we have 280 orders that were sent to Canada. Another way of doing or is by using the or, this or sign. So I can now return this to comma because we already have or. Then I can close this one last bracket. And we are still going to get 280. Can you see? It is still at 280. So any which one that you want will work. But I usually prefer working with this, with these two ampersands like this. Sorry, with these two all line, straight line. So yeah, that's how you do filters, right? And I hope it makes sense. It is a very, very easy concept to understand. All we need to do is just practice, really. That's all it takes. Just just practice. So and if you look at calculate in this filter function, if you look at calculate, you're going to see that you see there is also the calculate table function, but this is just a note for you. So you're going to say calculate the expression filter, then the expression. By the time you go through all of this, really, it says when there are multiple filters, they can be evaluated by using the and double ampersand logical operator, meaning all conditions must be true, like I told you, or by the or, then double straight line logical operator, meaning either condition can be true. So you can read, on all of this and check examples also, and you're going to find what they mean. So and that goes for every single thing that you find here, all except filter, first on blank, anything. So let's look at if conditionals or logical operators. So this is if. Can look at if, and if is going to be our first step into what do you call it, into column DAX. So everything that we've been looking at since, they are all measure DAX. So let's create column DAX. And the first column DAX that we're going to be creating is going to be to um, create a profit and loss and break even column. So instead of having just a profit table where everything is profit and we only have to check if something is lost by looking at the amount that was made, Why not just get a new column called um, profit remark, and we are now going to have profit, loss, and break even if it is zero, right? So how can we do that? Well, that is going to be a column DAX. Why is that going to be a column DAX? Because we expect a full column as our output. Our output is going to be a full column, right? So that is the reason why that is going to be the choice in this case. So we're just going to right click. We're going to click on this table name, and it brings out new column, or you can just right click on the table name, anyone. So we click on new column, new column. So we are here now. We are going to drop down this, zoom it in so that you guys can see. Then we can go here and say profit remark, and profit remark is equal to, we can add comment and say return a column or containing profit, loss, or break even based on the values in profit column. Great. So how does that work? We are going to use if. So we're going to say if now, if and if you are coming from Excel also, you understand this. If in Excel, in Microsoft Power BI, they do not behave like if generally, like do not behave like the if that you would find in something like Python, right? And the reason is because they cannot handle multi-domain problems. They can only handle binary domain problems. So in the case that you have multiple domain problems, we are going to see how that works shortly. But for uh, this situation here, I'm just going to show you the binary domain problem firstly. And binary domain means there are just two aspects to it, right? Either true or false. You're either looking at two sides of things. For example, you want to check if someone is male or female. You want to check if somebody passed or failed. You want to check just two things that have just one thing that has two possible outcomes, right? So let's look at that first. So we're going to say, and I said all of that to say that if in DAX, in Microsoft Power BI DAX, primarily it is suited for two outputs, binary domain, but you can actually configure it. There's a way for you to just work around it to handle multiple domains. You are going to find that out here. So the first thing that goes into if is the logical test. What do we want to test? So I want to test is profit. Is profit less than zero? Let's say less than or equals to, because in this case we are saying, okay, our uh, loss, our profit is only when we actually make profit. Any other thing is loss. So we say financial profit is less than or equals to zero. This is the logical test. All of this line is the logical test. Now we are now saying if this is true, if this logical test is true, what results do we want to see? We want to see profit. Just print profit for us. Else, result if false. If this thing is no, in this case this is loss, not profit. Apologies. Else, if this thing is not true, then print out profit. And that's the reason why we said this guy only works for, okay, we need to close that quote. This guy only works for, just the standard implementation of this guy is just for binary situations. So if I should press enter, that is almost done. I think it is done. I can make it smaller and get this one up. And if we go here, we have a new column here. And if we click on this arrow here to inspect what has happened, you see that we have loss and profit. Let me uncheck profit and just get loss alone and say, okay, Let's filter for loss and see all of the losses. So we can see all of our losses here. And if you go check the profits table, where is it? Okay, this profit table. So I can see that all of them are actually losses, negative, negative, negative. But there are some break evens there, zero, zero, right? That we are not accounting for because of the way we've structured our condition. So let's make it better. Let's make it better. And how do we make it better? By turning this from binary to multi-domain. So I'm going to remove all of this and write from scratch, give you another opportunity to see this thing over again. So I can say if profit is less than 0, that is going to be loss, comma. Now, what's the result? Result if false. Now, what I want you to know is there are three things that could happen here. We cannot either have loss, break even, or profit. We've handled loss. We are left with profit and break even. So we can insert another if there. We can say if again. That is everything that is left. Let's exact another if on it. Let's say if uh profit is equals to 0. So what do we do? We call that break even, right? And if not, that is whatever is left, we call it profit. You do that and close this and also close this. Then enter. And in the profit remark here, everything works fine. So if we check our loss now, you're not in the profit table here. Look at it, you're not going to find any zero anymore. And if we go back to the profit remark and try and get break even and click OK, I can see that all of our break evens 0, 0, 0, 0, 0. Then all of our profits, they are also going to be profits, right? And say okay. That is that. So that is how you do column DAX. That is how you do conditionals or logical operators in logical functions, sorry, in Power BI. And I've shown you and earlier, and is to evaluate multiple conditions to true or false. There is coalesce, there is not, there is switch and true. Switch and true, if you use switch and true, they work. Okay, let me show you that. If you use switch and true, they work exactly like your multiple condition problem. So I'm going to do that. Let's say I want to achieve this exact same thing, but I don't want to use this nested if approach. Let me show you a way, and that's just the last thing that we're going to be looking at in this particular series, in this particular course. So let's say I want to see, we want to look at situations where, let me see, let me see what we can do. Uh, okay, let's just write it for the same thing. I'm running out of examples in my head. So let's look at that particular profit remark table. So this profit remark, I'm going to write it using switch through. I told you can write it with switch through. So let's see. I'm going to remove all of this. If this is a video, you can always pause this part and write it down if you want to lose it and stuff like that. But the goal is to learn actually. So we want to achieve this exact same thing. Let me firstly show you this and say enter like this. You're going to see that this column is not going to be populated, right? Let's see. Um, Select all and say okay. Right. So you see that there is blank now because we've deleted the profit remark stuff, just so that you see. Now we're going to achieve the exact thing that we achieved earlier with switch through. So I'm going to say switch, and the first thing is we pass our expression to true. That is, if this particular thing is met, then the expression is true by default. And if it is not, it is false, which means that is only when we activate our else. So what does that mean now? The first thing that we're going to be doing is we're going to say what's the stuff profit. So we're going to say profit, financials profit less than zero. That is the value. What should be the result of that? The result of that should be loss, comma. And what makes this one a much more prettier solution is you are not nesting anything. There is no if inside. If it's just one straight line. So, and I find myself using it a lot, especially when I have multiple conditions, like a lot. I use it a lot. So profit again equals zero. That is going to be break even. And last one is going to be the else. That's going to be profit. Right. So if I should run that, and can you see we are back here? It works. It has filled it up again. And if you click on it, we can just click on break even alone. Let me remove profit and loss. Get break even alone and see if everything works fine. Can you see for break even, where's our profit? Zero. And it marked it all right as break even. If you check for loss and remove break even, we're going to say okay. And we have our loss and it is correctly mapped as loss, which is negative. So that is that. The last one I'm going to like to show you, the last variant of DAX, the last type of DAX is table DAX, right? And the most common one, apart from date and time and calendar stuff, is calculate table. So let's say I want to filter out. I can't even find where calculate table is. I think it should be on under filter. Yeah, it should be under filter. Uh, filter functions. So calculate table. Yeah. So this is a table DAX. Calculate table. So let's see how it works. If I want to get calculate table, let's say I want to only get a table of orders that were losses and that has high discount band. Like what are those orders that they resulted in loss for us and we still gave them very, very high discount? So, and we don't just want to see a column, we want to just get out the entire table. So what do? I'm going to click on this place, on this financials, right click and say new table. Do we have new table here? Nope. So what we just do is come to this place, then you see new table here. So we have new table, and let's quickly get that. So we're going to say, let's call it bad deals. Bad deals. Then go to the next line and say returns a table of deals with high discount and resulted that resulted in a loss. So how does that work? We're going to say calculate table, and the table name is going to be financials, and the filter is going to be, what's the first filter? The first filter is going to be discount band equals. Now I can't tell whether the I is capital H or small. That's the reason why I like staying on the data page. But we are going to go check back later and say, and it resulted in a loss. And we're going to say profit remark, that is going to be equals to loss, and close that. So if we do that, what happens when we run it? If we run that, we are going to get a new table. So we now have a new table of bad deals. Yeah, can you see? And this table, let me make this smaller. This table here has only bad deals in it. Can you see? It's a full table on its own. And this is all of the table here. So you see that we have all of discount band is high, and all of the thing resulted in what? In loss. profit is negative, profit remark is loss. So that is how to write a table DAX, and you see that it gives us a whole new table. Can you see? We have a whole new table called bad deals, which is here. And these are our original table here. But this is the table of bad deals. So yeah, that's that on DAX. Don't forget, if you need anything relating to DAX, really, there's nothing to memorize. There's no reason to memorize anything. The ones that you use um constantly, you're going to remember them. The ones that you don't, you can always come to this place and check how it works. And there are a lot. There are a lot. There are statistical functions, there are financial functions, text functions, a lot of them. But what everybody do, even the experts in the field, is they come to the documentation and check to see if there are things that helps them. If you want chi-square distribution, you probably read up on that and see the implementation. So thank you. That is DAX, and I'm going to see you in the next one.